transition from EBC C Sink to Global Biochar C Sink. We start with a short reminder on how certification in general works. So if we look at the Biochar C Sink certification, we start with the production of biochar, and all data that is relevant for the emissions that are related to the production are documented in the biochar tool. And after factory gate, the biochar will be handed over to a DMOE system that is then tracking the whereabouts of the biochar, but also documenting all the emissions that appear after factory gate, so while processing or while transporting the biochar to the final matrix where it constitutes a C sink. And whenever that's done, so whenever a C sink is realized, the data will be transferred from the DMOE systems via an automatic interface, the API, to the Global C Sink tool, which is the back end of the carbon sink registry, where the C sinks are registered. A verification of the C sink takes place by the VBB, so Ceres in our case, and then the credits are visible in the Global C Sink registry and can be transferred and retired by so-called C Sink traders. That's a role that we offer at Carbon Standards, to be able to retire C Sinks in the registry. And in the end, the public visible part of the product that we are talking about looks like this. We see that we have a C sink. It consists of 12 tons of carbon. We see the persistency curve. We see if there is part of the C sink retired already, and that's something new. We see the public documents, and that's how, or that's the product that we talk about, and that's whatever we do with the C sink certification leads to a C sink in the registry that verifies and gives the promise that there is 1 ton of CO2 stored in a permanent matrix. We had the EBC C Sink standard valid since a couple of years, and now at the 1st of July 2024, we introduced a new updated version, the Global Biochar C Sink. Then there was a transition period until the 1st of March, and with the 1st of March, the Global Biochar C Sink standard is the one that's valid for all companies, as well for the old companies, or for our old customers, as well as for new customers. As you know, there's a relation between the EBC and WEBC certification and the C Sink potential. For EBC, we certify the production of biochar, and it's a certification of the quality of the biochar itself as a physical product. So here we have a certification that is organized in batches, and the batch is registered, all the data necessary are entered, and then you get a batch certification. And that's a continuous process. So after 1 year, you close the batch, you open a new batch, and you get the new batch certification. And with this batch certification, if you are registered for the C Sink service, you also get the C Sink potential. The C Sink potential is a document that shows you how much CO2 is bound to the biochar and how much emissions have been produced in relation, or while producing this biochar, and the emissions are divided into fossil fuel related emissions and CH4, so methane emissions. And then, so there is a direct connection between the EBC quality certification and the C Sink potential. And afterwards, as I said before, it will be tracked with the DMRV system and eventually end up in the registry to be a C Sink that can be traded. Because of this direct connection between the batch and the C Sink potential, we face a problem if we say that the Global Biochar C Sink will become valid at the 1st of March 2025, as there are many batches that overlap this date. So here in this graphic, we just chose some random date. The date doesn't mean anything, but it's the date before the 1st of March and the end date of the batch is after 1st of March. So we would have these EBC certified batch and the corresponding C Sink potential. And now what happens is that on 28th of February, we will close the EBC certified batch and we will open a EBC certified batch for the remaining runtime of the batch, which has the same certification class, has the same analytic parameters, and will be automatically certified. So in the end, you will have EBC certified batches for the same period as you had it before, but it's just separated into two batches in order to have an EBC C Sink potential before 1st of March 25 and a Global Biochar C Sink potential for everything that is produced after the 1st of March. So what we will do for you is to close the batches as of February 28, to open even before before end of February, we will be opening new batches that will be valid as of 1st of March for the rest of the runtime of the batch. We will notify you that the follow-up batch has been prepared and you need to fill the remaining values. And whenever the remaining values are filled, a new C Sink potential certificate will be issued without any charge, and it is then a C Sink potential certificate according to Global Biochar C Sink standard. What you need to do is to submit a PDD, the project design document. That's something that will be explained in a few slides in more detail. And you need to fill the additional values required for the EBC, for the Global Biochar C Sink potential in the biochar tool. That's the case because we need a couple more data for the Global Biochar C Sink certificate than we needed it for the EBC C Sink. If you can't adhere to this process, the results will be that in the Global C Sink Transition Registry, where you can also have EBC C Sinks without PDD, you can issue certificates until the 1st of March. After the 1st of March, the transition registry will be closed and we will only have the Global C Sink registry open, where it's a requirement that you fulfill the public documentation. That means until you have a validated PDD, you will not be able to issue C Sinks, but you can issue C Sinks with the EBC C Sink potential even after 1st of March. So you can issue C Sinks also after the 1st of March, and that these can be either with old EBC C Sink potentials or with the new Global Biochar C Sink potential. And so that means that whatever you would like to issue between 1st of March and the date when you have a validated PDD would be postponed after the public documentation is ready and all the requirements of the Global C Sink registry that include the public documentation can be fulfilled. So that was the sum up of the content of the newsletter. And now we will have a look into the changes from the EBC C Sink to the Global Biochar C Sink standard. First, what stays the same? The general logic and approach stays the same. You'll still have annual on-site visits. And we will still have the EBC WBC certification as a prerequisite for the C Sink certification, as well as the batch-based C Sink potentials. We continue to have a restrictive monitoring and check of all emissions, and there will be the on-site verification of all the C Sink calculations. But there's also some important news in the Global Biochar C Sink. First and foremost, there is the public project documentation that's required for Global Biochar C Sinks. And in the brackets here, you can always see on what page and where, in which chapter or which point you can find the information in the Global Biochar C Sink standard. We will have a cradle-to-grave emission documentation. We published an application metrics positive list. We explicitly mentioned that processes need to be registered. We have an energy efficiency limit introduced, and we have the requirement to report the carbon efficiency. And that's the important changes regarding to the process. For the product, we have a updated product definition. We issue geological C Sinks now that confirm more than 1,000 years stability or persistence. We also introduced temporary C Sinks that cover everything up to 100 years. There is threshold value for the diffuse C Sinks, that's 1 ton of CO2 equivalent. We introduce emission portfolios. You have the possibility to offset methane with temporary C Sinks, and we defined for pro rata accounting or allocation. I will now not go into detail for all these points. If you have questions, feel free to reach out. For the other points, I will now only cover part of them. So the first one that I want to talk about is the public project documentation. And that is part of the C Sink certification process. There is a project design document with a monitoring plan that covers the eligibility criteria and refers to one of our approved methodologies. There is a validation report that will be the result of the validation of the PDD of Cerescert. Afterwards, projects are allowed to start the project implementation and operation. There will be a monitoring report that is part of or is automatically derived from Biochar tool. There is a verification report that is also issued by Cerescert, and then in the end, there is the issuance of the C Sink certificates. If we look at the project documentation, the main part is the PDD, and we have a system that has a distribution of the responsibilities for the parts of the PDDs among the different entities that are part of the distribution channels of the value chain of the biochar C Sinks. The main part is done by the biochar producer, as they know most of the relevant parts. So they know everything about the biomass, they know about the production technology, which is mainly contributing to the emissions that are connected to the biochar. But there's also processes that contribute their own part to the PDD in form of an annex. And in the end, there might be even more than one processor included in one value chain. And the last bit, the application to an accepted matrix, needs to be documented as well. And that leads to a PDD that covers everything from cradle to grave. And it starts with a general description. Then there is a forecast of the impact, so the amount of C Sinks that can be achieved with this project. Then there is a chapter that goes into detail about the project production technology. Then one of the important chapters, all of them are important, of course, but this one is the one that's important for the calculation part, is the chapter 4, where you have the determination of the C Sink potential. So that's everything until the factory gate, with a monitoring plan and the calculations. And then in order to determine the C Sink value, so the realized C Sinks, we need the processing emissions. So the PDD has a placeholder for processing emissions, which will be filled by the processor annex to the PDD. And then there is the next subchapter, that's the application emissions. And that depends on whether the producer himself does the application of the biochar. Then this is not a placeholder, but part of the PDD from the producer. If that's done by someone else, then that is also a placeholder. Therefore, it's yellow-greenish, because it might be a placeholder, it might be not. And in the end, we have the complete calculations with all the monitored parameters that we have here and here and here. And it shows how the C Sinks are calculated, so that in the end, with the PDD, all the calculations that are needed for a tradable or to understand how the tradable C Sink is calculated are documented in a publicly available format. This PDD will be validated by Ceracert, where they check whether the PDD is in line with the methodology. And they do first a desk review, and second step will be the on-site confirmation. The monitoring plan is one of the key parts of a PDD, where it outlines the future planned monitoring. The parameters are specified in the template according to the standard and represent an analogy of the fields from the biochar tool. So what we can see here is that we have these tables in the PDD where the parameters are listed, and the monitoring frequency must be given by the producers, and also the source of the data must be filled in by the producers. And these fields, so type of feedstock, they correspond to the fields in the biochar tool where you also where you will be monitoring the same fields. So we prepared a template for the PDD that's already customized to the methodology and to the monitoring tool that we have, the biochar tool. And as I said, producers specify how often they plan to monitor a specific value. Often the inadequate solution would be per batch, as our system is designed on batches, and specify on which data source this data is determined, and in the best case, in which timely resolution you have these data points as a backup or as the data source that you can then present to Ceracert whenever they do the audits. So there's just to be said to how the monitoring plan should be filled out in the PDD. So in the end, if we remember this graph, the project design document and with its monitoring plan is the part where the producer describes how they plan to monitor their activities. The validation step is the step when Ceres decides whether the monitoring will be sufficient to verify the authenticity of the information. The monitoring report is the data in the biochar tool with all parameters and data sources planned in the validated monitoring plan. So you have the data collected in the biochar tool, and you have to have the data sources ready for the audit. And then the verification is the step where the VVB cert verifies the reported data based on the data sources. Yep, so that was the deeper look into the public project documentation. Now I want to speak about the energy efficiency. We introduced an energy efficiency limit of 60%. That means that for every batch of a certified pyrolysis unit, at least 60% of the sum of the energy contained in the biomass and all energy expenditures of the process must be used. And they are below the they are the lower part of the formula, and above you have all the energy that you get from the process. So the energy contained in the biochar, thermal energy that you provide in the marketable way, energy that you use for drying, and electric energy. And the energy efficiency must be higher than 60%. There is exemptions possible, and they can be granted for up to 2 years if some of the following points are fulfilled and proven. You're running a pilot plant, or you had the development of an unused biomass potential for which another more energy efficient use is not foreseeable. This can be seen, for example, in a technical idea for increasing energy efficiency that can be planned or must be planned, that is preferably creative. And of course, we are willing to grant exemptions, but you have to show that in a certain time frame, you will be able to meet the 60% criteria. So besides, we introduced new product definitions. We have a geological C Sink, that's the C Sink 1000 plus, and that's, for example, the case for soil application of biochar with an H2C ratio below 0.4. There we know that we have 2 carbon pools in a biochar, and the pack fraction, so the permanent fraction that is highly stable for more than 1,000 years, constitutes 75% of the carbon of the biochar. And then there's the semi-persistent carbon pool that is 25% of the total pyrogenic carbon, which faces a degradation after time, and therefore doesn't constitute a long-term carbon sink with more than 1,000 years of stability. But for soil applied carbon, biochar with an H2C ratio below 0.4, you will be issued C Sinks 1000 plus for 75% of the applied carbon. And then we also introduced the temporary C Sinks that have the defined or shown by the underline and then the number of years. And that's, for example, the case for biochars with an H2C organic ratio above 0.4 that are applied to soil, because there only the SPC fraction is accounted for, and therefore it's completely degraded, but you retrieve the C Sink value from the integral. And then you could, for example, have a C Sink 100 derived from the SPC part of the biochar. And then there is the possibility to apply biochar to materials where we will be accounting for 100% of the biochar carbon, and we count it as a C Sink over the average lifetime of a product. So it might be that it's a C Sink 30, for example, where you get a C Sink 30 for 100% of the carbon included in the biochar. And for biochars applied to building materials like concrete, we have 100% of the biochar carbon for the lifetime of the building, and then we apply the soil degradation curve afterwards, as long as the ownership and the location is known. There's also a transition period for this until the end of 26. We consider soil applied, concrete applied biochar in the same way we do consider diffuse C sinks. So here you can see this as well. We have for the first 60 years we apply for 100% of the included carbon content, and then afterwards you have this degradation curve. So now we spoke about the news of Global Biochar C Sink standard, and I just want to remind you in the end again on this graph. So what you have to do now is to submit the project design document in order to fulfill the requirements of the Global Biochar C Sink and of the Global C Sink registry, where we need public documentation, and you have to add additional values after we contact you that we opened the new batches, because the Global Biochar C Sink potential attestation needs additional data, for example, to calculate the energy efficiency, or yeah, that's the main additional points. Yes. So whenever you have questions on it, feel free to contact me or to contact our service hotline or service email, and we will answer your questions.